Hello, and welcome to a little video about systems of linear inequalities. In number one, what I'd like us to do first and foremost is to graph the system of inequalities. Let's start with the first one. I'm going to graph it in pink. Now remember, we have a slope here that's 4, but 4 is really, 4 over 1. And our y-intercept is positive 1. All right, I'm going to put a dot on my y-intercept and then follow the slope going up 4 to the right 1. Next, I'm going to decide what kind of line am I going to have, solid or dashed. Look at the symbol. Am I going to have a solid or dashed line? Since my symbol does not have a line underneath it, we're going to have a dashed line. Next, we need to shade. We have y is greater than. Greater than means we're going to be shading above the y-intercept. My y-intercept is at 1. Then I draw an arrow going up, and that tells me that I'm shading on this side. I'm going to erase that arrow going up and shade in this whole area with pink. Decent, I think. Am I happy with it? I'm happy with it. Alright, now let's graph the second inequality. I'm going to do that in green. Here the slope is negative x, or is just a negative. We don't see a number. Remember that if we have an invisible number in front of x, it's actually negative 1, and we would write negative 1 as a fraction as negative 1 over 1. Our y-intercept is 2, so let's start there. We're going to draw a dot at positive 2, and then we'll follow our slope going down 1 to the right 1. We have a less than or equal to symbol, which means we are going to connect our dots in a straight line, in a solid line. Of course, it's going to be a straight line, but a solid line. I'm going to make a few more dots. I want to make this a bit more accurate. It's kind of bothering me because I definitely know I didn't make the pink one as accurate as it could be. I'm not going to start over. Am I? Maybe? No, that's fine. It's fine, Gumin. Let's connect the dots in green. We're going to pretend that's a perfectly straight line. Since we have a less than symbol, that means we're shading below the y-intercept. Below that y-intercept means I'm going to put my pen on y-intercept of 2 and point an arrow going downwards. So I'm going to shade this part of the line. Okay. Do you see where the pink and green overlap to make this kind of pukey green color? That is the solution to our system. We can also use part of the solid line that borders the shade, the pukey green color. That can also be part of our solution. Is 1, 3 a solution? Well, let's see. 1, 3 is right here. Nope, not a solution. Let's identify a solution. Let's go with something easy. How about negative 2, positive 1? Again, we can have solutions. Solutions exist in, let's maybe make a space there, exist in the overlapping shaded areas and on a solid line that borders it. And what I mean is I'm gonna kind of trace this in the purple. This part of the line, whoops, if you take a look at, whoops, the green line, I'm coloring it in purple now. This is part of the solution. Okay? That is allowed because it's on that border that has that pukey green color. The dashed pink line is not part of the solution, so we can't land on it ever. Okay? Let's take a look at number 2. Let's graph this inequality. First we have y is greater than negative 2. This, I'm going to do blue and purple this time. Maybe I'll make a nicer color combination. There is no slope. Slope is 0 here. It's a flat line. So what we're going to do is we're going to put a point on negative 2 and draw a line going horizontally from left to right. This is going to be a solid line because y is greater than or equal to. Let's think about our shading. Greater than means we are shading above our line, and I think it's easy to see where that's going to be here. Beautiful-ish. It's decent. I swear my notes on paper look so much nicer. I can stain the lines better. Anyways, let's take a look at the second inequality. The second inequality has a slope of 3. Remember that it's actually 3 over 1. It doesn't look like there's a number for the y-intercept. However, that just means our y-intercept is 0. So we're going to start by putting a dot on 0, and then let's follow the slope, going up 3, to the right 1, and I'm going to do that one more time, and in both directions, just to make an accurate graph. This is a less than symbol, which means we are going to have a dashed line. It's dashed because we don't have the equal to underneath the inequality. Okay. Less than means we're shading below our y-intercept. The low would be going down, so that's the side of the line I'm going to shade. That's nice. That's a decent kind of overlapping color. I like that so much better. Okay, so it's like a deeper purple. So, where can our solution exist? Our solutions can exist in that darker purple color or on that blue line that borders that darker purple color. Let me trace that in green so you see what I mean. No, actually, let me trace it in pink. You can barely see that. There. This part of our inequality from y is greater than or equal to negative 2 can be part of our solution. If it's on the dashed line, it can't be. Right. Is 0, 0 a solution? Well, here's 0, 0. It does border our dark purple, but is it on a solid line? No. Well, let's identify a point that is that is a solution. Well, how about 3, negative 2? Or, what was that? 5, 3. There's 2 points. Alright, onwards we go. Let's graph number 3. Oh, I think I meant to retype this one. Oh, that's fine. Okay, number 3. Let's start with the first inequality. Our y-intercept is positive 5. And then we go down 3 spots to the right 4. Based on our symbol, we are going to have a solid line because it's less than or equal to. That or equal to means solid. Okay. Since it's less than, we're going to be shading below the y-intercept. So it's going to be here. Oh, I remember why I did that second inequality that way. All right. Now, as we've been working on math, we have had some inequalities and equations show up with x and y on the same side. And I've had several of you asking me, well, how do we graph that? The easiest thing is getting y by itself. Well, let's do that. We have, whoops, I'm just going to rewrite it up here or down here. Where do I have space? Down here, actually. Let's do that. 3x minus 2y is greater than 4. All right, our goal is to get y by itself. So as you work on Mathia, you would do this on the side. Okay, so the first thing I'm going to do is I'm going to move that 3x to the other side. Since it's a positive 3x, the way that I'm going to move it is by subtracting 3x from both sides. They cancel over here, because 3x minus 3x is 0, and I'm left with negative 2y is greater than, can we subtract 3 x's from 4? No. So I'm going to write, negative 3x plus 4, because 4 is positive. Next, I need to get y by itself, I need to divide everything by negative 2. I'm going to divide this side by negative 2. I'm going to divide the 3x by negative 2 and the 4. Now, on the left side, the negative 2's cancel. I'm left with a y. Since we divided by a negative number, our symbol flips. You could put this into your calculator. Negative 3 divided by negative 2 just leaves us with 3 over 2. 4 divided by negative 2 is negative 2. So essentially that's what we're graphing. Let's do it. What color do I want to do it in? I want to do it in blue. Yeah. I'm going to start by putting a point on negative 2. And then we're going to go up 3 spots, to the right 2 spots. Since my symbol does not have an or equal to, I am going to make a dashed line. But you know what? I'm going to follow up 3 to the right 2 one more time, just to make an accurate dashed graph. Accurate enough. Since it is less than, we're going to be shading below the y-intercept, which means we're shading all over here. Our solutions can exist in this purple area or on that border of the pink. Right here, this part of the pink line. So, is 3, 1 a solution? Let's see. What do I want to use that's visible here? Will green be visible? 3, 1. Yes, it works. What is another solution? What's this point here? 4, 2? 4, 2. Fantastic. Now let's look at some word problems, because that's also something we've been seeing as we've been working on our online portion. Michael is deciding on a gym membership. He has no more than Y dollars to spend. Gym A has a startup fee of $95 and charges $20 per month. Gym B charges a startup fee of $10 and $30 per month. Let's write a system of inequalities to determine which gym offers a better deal, and X will represent the number of months. All right, let's start with Gym A. Michael has no more than Y dollars. So we're going to start with Y. Let's decide what no more than means. Can Michael spend more than the money he has? No. So Y is the biggest. So Y is greater than. Anything else that he spends has to be less than the amount of money he spends. The amount of money he has. Can he spend all of his money? Yes. All right, so the money he has is more than or exactly as much as he's going to spend. So what are we going to spend on Gym A? Gym A has a startup fee of 95, so no matter what, you need to spend 95 bucks and 20 per month. And we have X, that's months, so 20X. Whoa, come back here. Gym B. No, Gym B. Again, Michael only has Y dollars. Can he spend more than the money he has? No. So whatever he spends has to be less than that. Can he spend all of it? Sure. So the money he has is more than what he's going to spend. In other words, his spending has to be less than the money that he has, or just as much. Gym B charges a startup fee of $10 and charges $30 a month. Jackie is deciding on a phone plan. She has no more than one Y dollars to spend. Here's that thing again, no more than. That means any money she spends has to be exactly the amount of money she has, or less than that. The first company has an initial fee of $200 and charges $40 per month. The second has an initial fee of $80 and charges $60 a month. Let's do the same system of inequalities with X representing number of months. All right. Y is greater than or equal to. Again, because the amount of money she has to be more than what she spends. We're not going to go into debt. All right, company number one, $200 to start, and then 40 bucks a month. Gym number two offers a sign-up fee of 80, but then charges 60 bucks per month. In order to solve this inequality, we would have to graph it and see which phone plan would be best. Ooh, I like number three. I like problems like this. I'm excited. Number three, which of the following inequalities or systems of inequalities represents the graph? So first things first, let's look at what we can cross off in the multiple choice. We can right away cross off letter A because it has equal symbols. These are equations. So goodbye letter A. Okay, now let's take a look at B. C, D, and E. What's different? The symbols. All of the right-hand signs look the same. Okay, so what we need to decide is which way do we face each of our symbols based on the picture. So first, I'm going to take a look at the solid line. The solid line goes through here. That's 6, because it looks like it's going by 2s. 2, 4, 6. So 6 has the solid. Let's see what we can cross off. Here's 6. Does it have a solid? No. 6 has a solid. No solid. Solid. Okay. We're down to 2 choices. Heck yeah. Now we need to decide which way the symbol is facing. Because these are our options. We have shading above and shading below. Alright, well let's take a look. It looks like we are shading. Where's the shading? Is the shading above the line? Yeah, it looks like it. It is above it. So it's greater than. Where do we have it? Letter C. Fantastic. Easy peasy. Let's try another. This time we're going to create the symbols. I like doing it this way too. I'm excited for classwork. Anyways, let's complete the system. So we have 4 y-intercepts. It doesn't matter which one we start with. What do you notice though about every single line on this graph? They're all solid. That's the best part. we're all gonna have lines underneath. I like it. Line, 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 line. Okay, perfect. Now let's take a look at all the y-intercepts. And the easy one, the x-line, is the only vertical one. So, on that note, let's take a look at the x-line. It's that vertical one, it's this green one. Which way are we shaded? It looks like we're shaded to the right. Are the x's getting bigger or smaller to the right? They're getting bigger. So this is a greater than or equal to symbol. All right. Next, well, I'm kind of zoomed in. I'm going to do the 91. So that's going to be the blue line. Okay. Which way are we shaded? Above or below it? Well, let's see. It looks like it's below. Good. That means we're less than. Okay, what do we got next? There's 60. That's going to be purple. Are we shaded above or below the purple line? It looks like it's below. Less than. And lastly, we have the horizontal one. Y not equals 10. Well, let's see which one it is. Got it at 10. It's horizontal. Are we shaded above or below it? Above. So it's greater than. Very nice. Again, I was looking at the y-intercepts. Nope. I was looking here for the x, and then this y-intercept, and this y-intercept. You know me and my love for color coding. Yes. Alright. In number 5, the very last one for this unit, what I'd like us to do is decide if these points are solutions to the system of inequalities. The solution to the system can only lay inside of that shaded area or on that solid border. So let's see. Letter A, 1, negative 2. 1, negative 2. That's on a dashed line. That's not an answer. Letter B, negative 6, comma 2. That's not even in a shaded area. Letter C is 3, negative 1. Also not in the shaded area. Letter D, negative 5, negative 6. Yeah. Letter E, negative 2, negative 2. Also yes, because it's on the solid line. Okay, that's the last lesson for the semester. You did it. Good for you. If you have any questions, remember, you can always ask me or whoever else is helping you out in math. Bye!